states that waves while traveling in medium behave independent of each other. They retain their identity. Now this can be also quoted in another ways. As far as mechanical wave is concerned, let's say there are two mechanical waves traveling in a medium, and if these two mechanical waves arrive at same point disturbing the particle, so we can say the net displacement of particle which is subjected to disturbance will be vector sum of displacement due to individual waves. This is as a consequence of principle of superposition. So I repeat, students, the phenomenon of interference is based on two fundamental principles. The first being the law of conservation of energy, and the second being principle of superposition of waves. Please understand principle of superposition of waves very clearly. Principle of superposition of waves simply states that waves while traveling in a medium behave independent of each other. That is, they ignore the presence of other waves. We have read principle of superposition in connection with charges also. The same consideration over there, that is, charges behave independent of each other. That is, they are not affected by the presence of other charge particle. Now we can imagine a very different situation. Suppose this principle of superposition of waves is not valid, then we'll have a very strange word. We'll find waves of different nature mixing, and we'll have a very distorted situation. Now you are present in some space. Now we know that presently where I am speaking, around me there are different types of wave present. Now I need a particular receiver set to receive these waves around me, and there are different radio stations, and then there are different TV stations. We have programs from these stations broadcast or telecast at different frequencies. Now all these waves are present in this room or in any space. So had there been any mixing, and if principle of superposition would not have been valid, then these waves would distort and will get a very different word. It is because of principle of superposition of waves that we are able to hear different program clearly with no distortion and with no mixing. We just need to have proper instrument which can filter out and which can receive particular waves at particular frequencies. So that is the basic crux of interference. Now let's understand there are many more implications in interference. I said when we have two waves traveling in same direction. Now this is one of the requirement for any meeting of waves to be declared as interference. That is, two waves must travel in same direction or nearly same direction, and most important is they should have same frequencies. Now when we have two waves meeting under this condition, superimposing over each other, then there is a redistribution of energy in the medium. That is what we are referring interference. Now in the phenomenon of interference, waves may have a different amplitude. It may be equal, it may not be equal, but what is important is the superimposing waves must have same frequency. So this is one of the most important requirement for any superposition of waves to be declared as interference. And the second requirement is they should travel in same direction. So we can summarize the whole situation of interference saying that when two waves traveling in same direction of same frequency meet each other, resulting in redistribution of energy, then the situation is referred as interference. Now we find the phenomenon of interference in all types of waves, whether it is mechanical waves or non-mechanical waves. Here we are going to confine ourselves with respect to light waves only. Now the phenomenon of interference is found in sound waves also. So the very first point that we have to understand regarding interference, it is the phenomenon of redistribution of energy. When we are dealing with light waves, then it will be redistribution of light energy. When we talk about sound waves, there will be redistribution of sound energy. Now the second point, when we have two waves interfering, there are two possibilities. Now these two waves may help each other. Now when two waves help each other, or we say more technically that when they are in same phase, they help each other, and this type of interference is referred as constructive interference. And in constructive interference, energy piles up. Similarly, when we have two waves opposing each other, destroying the effect of each other, and we say when the two waves are out of phase, then in this situation interference is referred as destructive. And at the points of destructive interference, we have depletion of energy, that is, energy depletes. So interference is basically of two types. One is of a constructive type and other is a destructive type. In constructive interference, waves help each other, they reinforce each other, and energy at the points of constructive interference piles up. Whereas in destructive interference, the energy depletes, and at the points of destructive interference we have relatively less energy or no energy situation, and waves destroy the effect of each other, and waves are out of phase. So these are the fundamental points regarding interference. Now let's move into situation where we will be analyzing the interference of two waves mathematically.